Hey everybody, welcome to Houdini Hangout. It is the 4th of October, and we're back with another regular kind of weekly Houdini Hangout. If you Hey Ivan, sorry, I almost said even. Um, welcome. Um, if you were joining us earlier in the week, we've been doing some Monday streams for Mops Mondays, as we've been calling them. And tonight we'll be, hey Zach, how's it going? Hello. Tonight we'll be focusing on some non-Mops content. So that's the idea here this evening. And hey Epoxia. So yeah, that's the idea here. We're going to be talking a little bit about setting up some custom velocity fields. Oh yeah, Ivan, glad to be able to pick it. I felt like it was a good change of pace from some of the other things that we've been doing. Wasn't really specifically like, I mean, it will use some vellum grains to play around with it, but isn't really like a specifically similar setup to anything that we've been doing before. And I think it's really helpful across all different types of simulations. So happy to be doing that. And thanks for posting it. It's a great suggestion. And that the video that you posted that Mark Fancher had done is really cool. It's super, super fun. Obviously, we're not going to get anything that complex in a couple hours here, but we'll talk a little bit about how you can maybe drive, velocity information in a few different ways. So whether it's, we'll start, just with the basics of like how you're setting it up and then kind of go from there and play around with some different things. So that's the idea for this evening. That's kind of what our topic is going to be. Hey KG, welcome to the stream. As always, please, if you have any thoughts or suggestions, feel free to drop them in the chat. There's a million different ways that you can set up kind of custom velocity fields. You can drive it in a bunch of different ways. So if you have a suggestion like, hey, have you thought of doing this way? Have you thought of looking at this type of simulation or this way of sourcing them or whatever, different things like that. So we'll definitely look a little bit at blending between them and how we could possibly do that in different ways. Kind of the idea that you would do there with that type of simulation would be basically just pulling your velocities from maybe a couple different sources and blending between them blending between those two different sources. And we'll play around with some different ideas and ways that we could do that. I mean, there's certainly tons of different ways to be able to transfer velocity attributes into volumes. Some that are built in, some that you can kind of build from scratch using VOPs or Vex. I don't think we're going to do any Vex or anything like that to mess around with volumes. I feel like it actually becomes a little, sometimes can be a little cumbersome. Obviously, it might be a little faster, but we'll look at a few different ways of kind of setting those things up, working with them, and then, basically just, making some different types of noise or types of patterns or things like that we can use to drive our simulations. So I guess, obviously, like I said, if you have any thoughts or questions or things that you'd like to add into the conversation, please feel free to drop them in the chat. That's always welcome and appreciated. And don't feel free to ask me why I'm doing something a certain way or suggest a better way of doing it. I'm not the only one that knows how to do this stuff, and I'm certainly not the expert on it. So, I'm just here to kind of guide the conversation and work along with everybody else. So, I guess with no further ado, we'll jump over into some Houdini. Get started. So like I said, I want to do this based on some grains. I think that'll be probably the easiest and quickest way to kind of see our results, propagating and stuff like that. So first of all, what I'll do is go in here and save a project out. We're at 10:04. No, that's the wrong. 23. 10:04. And let's just call this custom. We'll call it custom velocities. I don't know. Sure. All right, so let's drop down to GeoNode, and we'll just call this basic velocity volume. We'll just kind of work with it from here, just to make sure we're all kind of thinking about this the same way and working towards the same kind of idea. So let's start with a box. We'll do we'll make it nice and low. Oops. Hello. Like so. Maybe even a little lower. Just a thin little layer should probably do just fine. We'll do a match size just to get it sitting on the ground. Set it to minimum. There we are. Let's do a vellum configure grain. And we'll do create points from volume. We're gonna need to change the particle size a little bit because I believe we need to lower this to be able to get some, some results here. So let's go down a little bit. Yeah, let's go a little further than that. Let's do that. That looks good. So we got a bunch of little points there. Let's do a vellum solver. Maybe add just one extra substep in, see where that gets us. Oh, need a ground plane, ground position. There we go. And there's our grains falling to the ground and kind of tumbling around. And what we're seeing here is actually kind of the instability of this simulation. So what we need to do is just maybe add another substep in there just to help make sure we don't run into any kind of runaway forces where it's trying to kind of calculate all of these things that are kind of stacked on top of each other. I'm not sure if more constraint iterations would solve that. I don't think it would in that scenario. So what it's doing is, as these things are kind of moving internally here, I think what it's trying to do is try to figure out the order that they're all supposed to be stacked in, but it's creating kind of some almost like noise in there, the randomness that's happening. So, you need a little bit more than that. So we'll just do 3 substeps, do it like that. Cool. Great. Looking good. So let's now kind of make some sort of a volume that we can use to kind of advect our points around, right? So there's like I said, there's several different ways that we can go about doing this. Let's first just make, maybe we'll add like a bound to this, make it a little bit bigger, just give it a little bit of padding. So we've got a little extra, maybe we'll do 0.1 padding just to give ourselves a little bit of extra. I'll do it from the matched size there where it's on the ground. So we'll do a bound like so. This will just make sure that, like, as we have our grains here, we've got a good little bit of kind of border that we can work on. We probably don't need it to go under like that, so we can actually set that to maybe just a little bit like so. So there's like our little kind of bounds that we'll set up our velocity field within. Now, obviously, we're not going to be creating this velocity field outside of this, so you have to kind of be mindful of that when you're creating a velocity field, just to not, to give it a bounds that makes sense. In this case, we're just doing some really basic stuff, so this shouldn't be much of anything. So what we can do is do a, we can create a volume from this. We can make a vector volume. We can call this val. And we are going to initial value. Right. So this is, actually, should we do it? Sorry, my brain is shutting off for a second here. Let's do that from an ISO offset. All right, so let's just let's do this instead. So we'll do a volume here. Hey, Shaz, I don't know how to say that full name, but welcome. Welcome to the stream. All right, so what we need to do here is we'll just grab the bounds from this for our volume. So what we'll do is just do bbox here, and we will grab the surface node here, which is going to be the bound. So we'll just do bound 1. Like so, and then do dx size like that. And this will start giving us the properties from this bound that we can work with. All right, so let's do this. It's probably another easier way of doing this, but for some reason my brain's not working right now, so we're just gonna go this way. Z size. All right, great. So, hello, Z size. Okay. Okay, so let's do this here. We're gonna do this. I guess we can do it by max axis. We'll do this like 100, center 0, 0, 0. Oh, right, vector, val. I don't know why that's not visualizing. Doesn't look like it's showing up there. There we go. Okay, no idea why that was happening, but there it is. Okay. Weird. Weird. And what we're going to want to do too is get the center of this, which we can do kind of the same way. We can just grab the centroid, do the same thing. So we'll just do bound 1, and then we'll do, what is it, dx. Oh, I didn't close that. Parentheses. There we go. All right. So what we're going to do here is we'll just use the same. We'll just change these. What did I hit wrong there? dx, dy. Oh, lowercase c. Hey, Paolo. Welcome to the stream. And that's just going to orient it the same as this bound. So now we've got our volume here. We've got val xyz set up there, and we can start, kind of doing some stuff with this. So what we could do is we could do a, let's see, velocity. We could do use a volume velocity. These are going to be the velocity volumes that we're going to use. And this node here has actually quite a few things that we can use to kind of create custom velocities, right? We could add vortexes here. We could add curl noise to this. We could add velocity from points that's coming in on the second input here. We could add velocity from an object, all sorts of different things that we can use to kind of build our velocities in this way. The other thing we can do here, we could do a scatter, I believe, this way. Yep, cool. And we should be able to... So I'm just going to scatter kind of randomly like this with maybe just a little bit of a... just a slight bit of relaxation there. And we can do velocity... what is the name of it? Volume trail, not velocity trail, volume trail. There we go. So what we can do here is we can go, thanks, Val. So we can grab the points that we want to trail, our velocity volumes, like so. and we can do a bunch of stuff here. Now, this is set with an initial value, so if we set that back to 0, we should be all set. If we wanted to do something like a vortex in here or something like that, we could set that as well. Let's see here. We'll just set this really, really low, something like that, 0, 0, 1. Cool. So here's now, a velocity, kind of a vortex that would be coming in here. And we can change the amount of velocity that's being, added in here. And what this volume trail does is kind of starts from each of these points that we've sourced via this scatter, and allows us to kind of visualize what's going on in here. And we can look at these trails and kind of visualize them at different lengths and see kind of how it's going to work. But obviously, this is now starting to give us some actual velocities that we can work with. So let's do this. Let's do a null here that we can reference in to our solver. So let's just call this velocities like that. Color that yellow. We'll come in here and we'll just do a pop advect by volumes. This will be a nice, easy way to do this. We can point to a SOP. We could also point it to a context geometry, but if you remember, we're actually a couple levels in deep here with this Vellum solver. As far as like once you go inside here, there's actually a few more, levels that we've gone into here. So what we've done, so we're jumping in here, so we don't really have a way to easily access these first, second context geometries. So we're just going to set this to a SOP path that we know. So here's going to be where our velocities are for sure. And this is going to be important to be able to control how this works. We've talked a little bit about using, velocities and things like that. But this will be a little bit different because we're going to sort of be using some different. This should be over here. My bad. This should be on the force output, not on the source output. So what we might need to do here is increase the velocity. Maybe we do this to 10. I don't know. We'll see if we get any source in here. But this is also incredible. I did that actually incredibly lightly here because I didn't want it to go too crazy. So let's just set this to maybe to 1. Exactly. Yes. So I was just about to reference that. So Zach, you're asking, are the points in the volume trail there just to visualize the velocity? 100%. It's really hard to visualize this kind of random, just shaded area. And so when you scatter the points in, those act as sources. Carlos, I was doing the ISO offset for a second. And the problem is that I don't have a way to set this up as so I have it as a fog volume. And if we set it to vel, right, that's sort of the same thing. But I was realizing that there is no way to, if I just set this 100 for right now, there is no way to set it as a vector field, which is interesting. I didn't realize that. So you'd have to do some other stuff after the fact, like duplicating your volumes. Cloud might be able to work. Let me see here. Source geo. Yeah, this is going to do something a little different here because this is going to create a density field, right? So this is a little bit different as well, and there aren't the controls here to set that up. So what you need is this, you need a vector volume, or in this case, it's 3 volumes that sit next to each other that each have the X, Y, and Z component created. So that's one of the important parts about it. But it's a great question, Carlos. And that was actually what my brain was kind of going, wait a second, why is this more difficult than it needs to be? And I really feel like there should be an easier way to do that, honestly. So the VDB from polygons. So if you did VDB from polygons, this is going to sort of do, VDB, just the straight VDB node. You could do that actually. I don't know if that would allow you to, sorry. This actually probably would be, is it staggered vector field? Yeah, so you could probably also do this, and let me just see what this is setting. That's just setting a velocity. So if we did fog volume and vector float, like so. Yeah, you could do this as well. This would certainly work as well. Frustum. Yeah, so if we just took these same things here, copy parameters, paste expressions, that's going to do that. And then if we take this, copy parameters and paste expressions here. So now we have a VDB that is in more or less the same setup here. So the only thing I'm going to do is set this to just a really low, let me see, actually, sorry. I actually don't know if that is, yeah, so that is one of the tricky things about the VDB. We actually have to activate that. Oh, sorry, no. By size, we don't need it quite that small because that's going to be a bunch of them. But like, even if we did this like background value of 1 for all of these. See, these aren't actually activated right now. So you'd have to do VDB activate, I believe. And yeah, so this would be, I think, what you'd have to do, like this. Yeah, like so. So if we did this, that, and that. Now, yeah, I think that's more or less doing what we want it to. However, this is really low. Why is that so small? That's really weird. Yeah, and it doesn't seem like it likes working on this volume velocity. I don't think it's liking doing that. So I think we might want to, yeah, I think we're going to stick with the volume here because I think this volume velocity node doesn't work as well with VDBs because with a VDB, what you would do, it's they're constructed a little bit differently, so you can actually have a vector VDB. So maybe what you would need to do there would be to do this and do just a float, and it'd be val.x, and then this would be val.y. So it looks like we're only getting one of those going through. Val.z, fog volume float. Great. Now we should have 3xyz. Activate those. Those are all activated. Let's see if that'll work. No, still not doing what we want it to because it's not like adding the same velocity in. So let's just stick with this volume method for right now. I'm actually not sure why that's not working the way it is, but I'm assuming it's just because it's a VDB and it's reading it differently for that specific node. So anyways, we've got this stuff going here. Let's up the angular velocity a little bit. Here, cool. Okay, let's see, get that going there. There we go. So now obviously we're just throwing our stuff everywhere, right? So we've gone a little crazy, but let's reduce the speed of this a little bit. And so there now you can see that we've got kind of this velocity volume that's just kind of this vortex that's spinning around here and just moving our particles. Now, there isn't going to be any, let's see here. How can we visualize this a little bit better? Let's do color. Um, that's interesting. That's interesting that there's a expression in there by default. Normalized age. I think what we could do is ramp it maybe based on if we did length. Oops. Do this where we could ramp it based on velocity. Yeah, cool. All right, that looks good. Let's just pick some colors here. So we'll just do, actually, no, we'll just do like we'll just do like the infrared colors. Should be a little easier to see. All right, so now we can kind of see the velocity. These, I'm just basically coloring these based on their age or whatever. But oops. So here they are, kind of moving around. I'm going to change my background to be probably the dark gray. I think that'll be a little easier to see, maybe, or maybe even the dark black. Cool. So you can see that these once these particles come outside of this velocity area, the velocity is obviously not being applied to it anymore, so it just kind of dies off and they get deposited there, right? So we've basically cleared out all of the particles from this kind of inner area, right? So as they pass this region here, they lose their velocity. Basically, they're not getting updated or advected by that velocity anymore. So this is obviously really, a really basic setup. This isn't anything overly maybe interesting, but let's kind of play with this a little bit more and see kind of how these different things work. So like if we added in some curl noise here, let's maybe lower this a little bit so we don't have to fight these two things together. Yeah, let's do that. Actually, no, we'll do like 2.5. Let's add maybe 2.5 on the curl noise as well. And so now we'll have like this noisy kind of thing happening here. In fact, that's probably too much. Let's do a little less. Just want to kind of add a little interest to this. So the curl noise is going to go in all directions, right? So it's going to try to lift it up a little bit as well. It's probably not going to be enough to get it outside of gravity here, but we're just going to be kind of adding in some velocity here to this vortex, right? So this vortex is kind of shifting and moving and things like that. However, it's not just a straight spiral anymore. Now we have kind of particles moving around doing different things. So it's a little bit, maybe a little more interesting here. We can probably even do this at like 0.5, just so it still feels a little bit like it's rotating, but not so much that it's getting too overwhelming or whatever. So we can kind of play around with those values a bit. So this is the way that you can kind of take, we're starting with with a volume, right? We're starting with a volume velocity, and we're adding these attributes into that volume, right? We're setting the properties of that volume. So each voxel in that volume is getting a value that's saying how far these things should be pushed in X, Y, and Z. So that's what we're doing with these nodes here, right? So with this volume velocity node, it's looking at the noise that we're adding here, this vortex, this curl noise. It's looking at that as we're going through time and changing each and every one of these voxel cells that we've created here so that we can then visualize or then add that velocity in depending on where those grains are in the simulation. So we're taking just basic noise, and if we watch this, we can kind of see what's happening here too. So this is actually our noise field and how it's kind of evolving over time. So we can sort of see the speed at which this is moving here. This is the curl noise that we've added. Now, when we look at, if we turn the curl noise off, what we're seeing here is kind of strange, right? It doesn't really make sense, but what it actually is that we're looking at fog volumes, right? And fog volumes can only visualize positive values, right? So we're looking at this and we're seeing that there's 3 volumes here that are on top of each other, and they're showing different properties. So when we get over to this side here, all of our velocities are in the XZ plane, right? Nothing's really happening in Y. So everything here starts to become negative values as we go around. Then only one of them is positive as we're going this way, right? Let me see if I can turn my scene so I can see which direction I'm going here. So yeah, so over here, we're starting to rotate around. So we're going in both negative X and negative Z. Then we start going only in negative Z and start adding in some positive X. Over here, we're both positive, so that's why it's white. And then over here, it's back to that kind of half. It might be a little hard to see. It's pretty obvious on my screen, but there's kind of these distinct 4 quadrants. So we're setting the individual voxel properties of these volumes to be able to push our objects around, right? So that's how we're storing those velocities and then transferring them over into this solver, right? So just hopefully that's starting to make sense as far as what it is that we're doing and how this is actually transferring the volume into the grain simulation and how those are working. So the interesting thing that we could do here is we could use, a bunch of different ways to kind of create this volume velocity, right? Right now we have our volume here, and kind of the one benefit to using a straight like Houdini volume, if we look at this, these are standard volumes. One of the benefits of that is that we can actually, there is no pruning of that. There's like in VDBs, when you make a VDB, it tries to like optimize itself and kind of take out areas that aren't being used. But in this case, we have kind of this base, volume throughout our entire thing. In fact, I think if I turn this to 0, we should still see, yep, we have 100 by 100 in this case because we have the sampling divisions at 100 on each side. So we still have values here, even though the initial value is 0. So we're not running into any weirdness with like, oh, we have to activate the voxels to be able to add an attribute or add a the attribute into that voxel. So it's a little hard to visualize these things. So that's why we do things like this volume trail here to be able to kind of see. Oh, cool. That's great. Actually, I didn't even play with that yet. Ops plus modifier, probably tools. Say my velocity field node. Where is that? Oh, here, right there. Yeah, I see it. I did. Yeah, there it is, velocity field. Curious how that works. Oh, wow. 3. Put geometry or point cloud. Containment SDF. Background velocity field. Okay. So what this is doing here, I have a feeling is, I can't go inside. So I have a feeling that if we did this, and we need an SDF from that as well. So what I think how this would work would be we do a VDB from polygons. We can create this as an SDF. We can throw that in here, and hopefully now. We have a velocity VDB. Let's see. See if this does anything for us. Just going to kind of sort this around real quick. I haven't played with this at all yet. Yeah, I'm not gonna waste any time screwing around with that right now because I haven't played around with that, so I don't really know all of the ways that functions. But the reason that we're doing this velocity trail here, that's great though. I'll have to look into that and see what we can see if we can get into something with that maybe on a Mops Monday or something. But anyway, so this is a good way to visualize these trails, right? You can obviously change the length of them and see them longer or shorter, whatever. But let's say you wanted to do something where you were doing some sort of maybe a more custom, velocity type situation where maybe you wanted to do it based on the fall off to a certain location. Let's maybe start with that. We'll have some noise and we'll affect that based on, the fall off to maybe a point in space. That'll probably be the easiest way to sort of do that. So here's our simple setup. We'll just kind of call this our kind of simple starting point here. And we'll kind of move on from there. I'll add some curl noise into that just so that's got a little randomness to it. Cool. Awesome. All right. So this is the basic velocity volume. So now let's do, say velocity fall off from point. So if we did something here, we'll use the same vellum setup. We have our volume still. I'm going to take out this volume velocity because we're not probably going to use that in this case. The scatter should be here. No, sorry. No, that's... let's see here. We'll just do a VDB from polygons. I'll just get the density from this. I don't know why. How did I have that set up before that it was working? Anyways, we'll just do it like this with density. Great. It's nice and simple. All right, because we need a density for it to scatter inside of, so that's what it's wanting. We don't have any velocity at this point. So let's grab a volume VOP. Let's do this. We'll use this and we can adjust some of our velocities based on this. So we'll just say calculate velocities. I'll call this volume. So what we're going to do in this is we're going to read in our this volume VOP is, if we've talked about this a little bit before, this works differently than a standard VOP because obviously it's working on volumes. So you get some different properties that come in here. And by default, it has this density setup. We're not even going to be worrying about that. So we'll just disconnect that. We don't need that right now. Let's do a bind. And we should be able to grab a vector from val. In fact, hold on. Let me just do this first. Let me say bind. Oops. Bind export. Do the same thing with val. It's going to be a vector. And let's just set a constant here just to make sure that we're getting our properties out of here before we start worrying too much about all of the fancy stuff. So we'll just do this. We'll just say, give it 1. Yep. And there we go. It looks like we're already starting to get somewhere here. And if we look at our volume trails, sure enough, we've got velocities moving in that direction. And so we're working here. So we're working on our volume VOP. So the thing to keep in mind is that even though this has 3 different, velocity fields, right? So it's got an X, a Y, and a Z field. When you reference something in this, in your VOP, you can just say vel. You don't have to say vel.star or anything like that. We can just say vel and it'll actually pick up the things that we want. Let me take a quick break here. Let me know if you guys have any questions about that so far. Hopefully that's making sense and we'll continue on, but I'm going to give myself a little drink here real quick. Yeah, so so what I'm doing here is I was thinking I needed to import it, but I actually don't need to because we don't have any velocities coming in. What you would need for that is like say, so this is our actually that's a bind import. I don't know why I did that. Bind. So what I would need to do is do this, do val that's going to see the same as this one here. Oh, I guess I did that right. Anyways, so what this is doing is this is bringing in that velocity field. So say I had this volume, I don't know, going up right now, right? So it starts with an up velocity, right? And in here, I wanted to do something with that. Well, what I would want to do is do this, right? So this is going to pass it through, but now I can have like a constant in here and say I wanted to add, I'll just do a vector. We'll do an add, and I'll just add in a constant of like this with 1. So I have 0, 1, 0, and I'm adding 1, 0, 0 to it. So that is what's happening in here. And then when we look at this, now we see that that's at an angle. So as I change, I'll keep that visualized. As I change this here, you'll see that these are going to kind of adjust and change, right? So I'm bringing velocity in with this bind import, or just straight bind, adding those values and then bind export. That's how we send it back out. So yeah, it can be a little confusing because the nodes look the same. So and in fact, it even has this input when you do that. So it's a little weird, but we don't really need this import here because we're not going to be using the values that are coming in. We don't have any values on it, so it's kind of pointless. So let's do this. Let's also grab, let's grab an add node. And to be a little cleaner here, what I should probably do is do something like this. Add a null here, call this like volume or like vol bounds, something like that, and reference all of my things here from that. That would really be the cleaner way to do it, because then you know kind of like a specific spot and it's not a node that you're referencing. So that really is a better way of doing that. So do as I say, not as I do. Okay, so let's grab just an add here, and let's do this. Put this into our second. We'll grab a point here, and we'll just sort of, let's hit enter, and we'll just kind of get a point somewhere here in space. So that's going to be our location that we're going to calculate this based off of, right? So, okay, so we've got, we're creating one point here. We're going to calculate velocities maybe based on that. So what we could do here is we could grab our current point velocities to this, right? And we could do something like we could calculate sort of like the distance from that, we could calculate the distance from that point to somewhere, in our volume. That we can certainly do. We can also calculate the vector that's pointing in that direction, right? So let's first calculate the vector to point in that direction, right? So what we need is we need to get that point, right? So let's do a let's see, Yes, exactly. So in this case, we want the point to be inside the volume range. I didn't double check that, but I'm pretty sure it is. Let me just see what the bounds are. Yeah, for sure. So I think we'll be good there. Yep. So we just set this somewhere in here. It doesn't really matter for right now. But yeah, it has to be inside of the bounds. The point we're seeing there is actually the volume points. So that's why we're seeing that visualized. So I'll do an import point attribute. My brain was not working there for a second. We're going to bring this in from the second input. Actually, we don't even need to wire that in. We can just do vector 3. We can say second input. The attribute's going to be P, and the point number is going to be 0. We don't really need to worry too much about that. If we wanted to, we could maybe iterate through that using some sort of a property. But in this case here, we don't have, or an attribute, we don't have, we're not iterating on point numbers, right? We're not doing any of that kind of stuff. So we don't have a point number here or anything like that to work off of. So in this case, we're just going to grab point number 0. That should be fine. What you could do is obviously set something like, you could promote this parameter. You could set a constant, however you might want to do that. I mean, maybe the cleanest way to do that would just be to have a constant here. That's the point number. It's 0. So this is going to bring in our P, right? And if we take this, and I believe we're going to want to do a subtract. I always pick the wrong one, and I think it's subtract. I'll probably mess this up, but we'll do it like that. And now we'll have, we're basically taking these two vectors and doing calculation on them and getting out our velocity. Let's see how badly I messed that one up. No, that seems relatively right. I think that will be right. We'll see. So what this is going to do is add in velocities to our simulation. So let's see if this is going to pull or push these. It does not look like we're getting anything there because it's probably too weak to be doing anything so far. So what we could do here is we could set a multiply. We could promote this parameter and just, I'm clicking on that little nub there and say, we'll do that. And then we've got our scale velocities property now that's up here, and we can just set this to, I don't know, 10 for right now and just see if that gets us anywhere. Sure does. Pushes them all away, right? So should have probably been an add that I should have done. See here, it's just going to blast them all away really quickly, right? But it stops when we get to the boundary, right? So let's do this. So should they be switched? I think that's right. So now this should pull it inwards. I'm not going to set it to 10. Let's do it to like 5. Kind of play around with some of these scales here. Not 100% sure. Yeah, see, so now they're trying to pull back into that position. However, they're all trying to kind of go back to that point, right? So this is fine. It's doing something that we want it to do, right? Where it's pulling these particles towards it, right? However, they're all kind of now bunching up on top of each other. So we can do it that way. We can also, I'm doing Shift R here to switch these. So we could do this as a repulsive force this way, right? And they're going to kind of push away. And we can control that with our velocity here. So maybe we'll set that to 5. That'll be a little bit more reasonable. Cool. So what we're getting here is these velocities, right? That are increasing as we go away from this. And that's kind of not what we want, because really something like this would make more sense if we had it stronger the closer it is and weaker the further away it is. So let's do a couple things here to kind of fix that a little bit. And again, I'm doing a lot of this on the fly, so if I'm thinking about something wrong, please drop it in the chat. I'm just kind of spitballing here as we go. So always welcome. So let's take this, let's look at what these look like here. Let's visualize these, right? So we can see here that, obviously these are all pointing away, but they should be shorter. Let's see if we look at this here. Yeah, it's kind of hard to visualize here, but these vectors should be shorter the closer they are to the actual point source that we're working off of, right? Off of this point source. So as we move this around, we're going to see that those all change, right? They're all going to kind of move around and change. Now, what we should do here is let's normalize this, right? Because right now all these vector values are in varying lengths. So let's normalize them first, right? Let's give these a normalized, let's do that here. So we'll normalize those values. So now they should all be exactly the same. And so now we shouldn't have it where it goes faster the further away it is. It should just basically move away at kind of a uniform speed. Let's just set this to maybe like 1 for right now and see where that gets us. No, it looks like it's going to be a little too weak. And just remember that I'm coloring these based on the velocity, so that's how I'm kind of visualizing those. All right, so let's boost it a little bit here, maybe 2.5. See how that goes. There we go. So now it's just evenly spreading across that. We're not getting the speed up as we get to the edge, right? It's just evenly spreading, right? So that's great. So we're starting to get somewhere, right? Because now we have all of our velocity vectors that are in the exact same length. So what we can do now is start to play around with this a little bit, right? So instead of doing so we've got this value here, right? Where this is our vector length, right? So what we can do is we can take that and do length here, right? And this is going to allow us to get the length of our vector within this kind of area that we're starting to look cool. Yeah, it's it's a process. It's not, you can't just instantly throw this stuff down and start playing around with it, because you got to set some stuff up, right? So now we have this length here, right? And if we take our length what we should do, is do distance. That's my bad. We should do the distance, not the length of that. That's wrong. Should do the distance here. So we're going to take these two, because this is our incoming point position. This is our position. I actually didn't even explain that. This is actually the position of the current voxel that we're calculating, because we're going over every single voxel in this, right? So that's the current voxel position. So I'm just going to move this down here. So now this is the distance between those two. And what we can do is let's do a fit range. And let's promote these here. Oh, that's right. You can, I just remembered this. You can do this. I think you can right click on this. There you go. Create input parameters. Boom. All promoted at once. Very nice. And then let's take this. We have already our normalization. We have our multiply based on an overall scale. Let's take this and do another multiply here. So as of right now, this is going to be clamping this fit, right? So this fit is going to clamp based on this range. So if we come up here, we can see that this is 0 to 1. If we look at this here, it shouldn't really matter, because I think they're all past a meter, I'm guessing. So let's adjust this here. And so what we can now effectively do is adjust how this is going to multiply into here, right? So what we can, we're going to take these last two and flip them, right? Because we don't want it to be 0 when it's close. We want it to be 1 when it's close and 0 when it's far. So now we can take this and kind of adjust these values, right? So now we could do something like this, where we have our velocities calculated like this, right? And as we simulate this, we're just going to get a little force added in here, and it's just going to kind of push away in that area, right? And if we had this animating, right? So let's just animate that real quick. Let's just do like this. I'm going to turn the sim off for a second. Just do that. Maybe over here. And then here, and then we'll maybe have it go up here, and then back over to this area here. So now we should have, so if we watch this, let's just watch this before we watch our simulation, should have a moving velocity field now, right? That we're going to put through this simulation. Okay, so that's kind of interesting. So now let's take that and look at this here. Yep, and we're starting to get something going on here where we're pushing these particles around, doing some interesting things. Now, granted, the colors, like I said, are simply the colors are simply just how fast they're going, their speed basically. So that's what we're kind of visualizing here with the color. You could certainly delete the color attribute. It wouldn't, you'd get your result kind of as is. But so what we're getting right now is kind of putting these forces in here, right? And starting to, do something sort of a little more interesting with this. So we've got this kind of randomized kind of visualization of what these forces are, right? So, okay. So we're starting to get somewhere here. Now we're starting to kind of get some interesting velocities going. So Ivan, you asked, could you explain again what the distance node does? For sure. So the distance node, really you can think of whenever you're in your VOPS context, you can think of each of your nodes as like usually some sort of little function, right? If you were writing code, it's your little function, right? So the distance node or the distance function is basically looking for the distance between 2 points and outputting that as a value. Now we can't see that easily here because this is a volume, and so we're not going to be actually querying all those individual point, attributes and things like that. But what we could do here, let's just do this just for kicks. Let's do a bind, and I'm going to, bind export. What did I do? Fat finger in it here, and I'm just bumping every wrong key. All right, so let's do this. Let's do this as dist, and I think we can do this as a float. Will this work? No, it won't work like that. So let's do we'll just copy this, and we'll also set a dist volume. I'm going to merge these together. And instead of a vector, I'm going to do this as a scalar. Call this dist. Great. So now we have distance and velocity coming in here. We're going to calculate both of those, right? Or all of those. So now we have a distance field as well. And what we can do is we can blast based on our... Yes, exactly. So if we blast based on distance, we can actually sort of see this, right? This is sort of visual in here, right? So you can see the distance being calculated and kind of exported into this field here. So wherever our center of this is, we see this kind of field, this volume that sort of follows it around, and we can see the values that are set. One at the high, in this case, we've actually remapped our values, but what it would be normally is 0 in the center. So normally it would look something like this, right? Where it would be sort of, let's make this a little more obvious. Something like that. So it would be 0 as you're close to it and 1 as you go further away, right? But in this case, we're seeing the, oh, right. I'm deleting the wrong one. That's what I should be deleting. Sorry. I'm like, why does that look so weird? I deleted distance and not delete non-selected. So that's what we'd want. That's what we would see. So that's our field if we had it by default. What we're doing though is we're flipping these. So we're having it 1 close and 0 far. And there you go. Now you can see this kind of, it's actually a sphere that's going around it. So let's see if we can see that a little bit better here. So if we were to make this a bit smaller, you can see here we actually have a sphere around that point. So it's actually, obviously a 3-dimensional region that's kind of surrounding that. So we can set our fall off based on that and a whole bunch of other things. So if we only want it to be affected in a small little region, we can look at it like that. And then, it's probably not going to be able to really do a whole lot here. It's just going to be a little bit of pushing. It's really not doing too much there. Let's do this. Let's go a little further with this. And yeah, so you can see that you want to give a little bit of region for this maximum value to be able to kind of take hold, right? Or in this case, the minimum value, quote unquote, but we're flipping it, so it's inverted. So yeah, so we're using this range between these points to kind of calculate this in a certain way. Give it a little fall off like that. And we're off to the races to start, doing some stuff here. So obviously in this case, we're just doing it from a point. This isn't like the most groundbreaking thing that we could possibly be doing, right? It's pretty simplistic. But let's say we wanted to do something, let's just say we wanted to do something where we had, an object in here or something that we wanted these particles to kind of move out of the way of, but move around or something like that, or have some sort of force that they would kind of avoid or whatever. So, we're obviously starting to get some of these things here, but right now we just have set up basically repulsive force. How would we do something like, a force, some sort of force that would rotate around or something like that. Well, let's think about this. Let's think about what we could do here. Let's grab. Okay, so I'm gonna get rid of this distance thing. I don't think we really need to have that. That was more for just visualization. I'm gonna get rid of this in here. So let's set up another node here so we can kind of keep this and continue on to another kind of part of this. So let's do maybe a fall off instead of from a point. Let's maybe do it from a curve now. Let's do something like that. All right, so instead of a point here, let's get rid of our point. Let's do something like, I don't know. I'm trying to think. Could try the pig head. It might be a little much, but let's maybe give it a shot. Why not, right? Old pig head. Okay. So we've got some geometry now, maybe that we want to get some attributes from, right? We want to be able to get, some sort of a, some sort of a velocity from this or something like that to kind of move our sim around based on this shape. So, obviously what we could do here is we could try to add some sort of a, we could add some sort of a vector on the surface, right? We could add something like a polyframe, add that here. We could look at something like the tangent U, which is all funky because it's a little too big. So let's just go in here and visualize this a little smaller. We could get these kind of tangent attributes and things like that, but these are a bit kind of all over the place. They're not really very controlled. So let's instead convert our geometry maybe into some sort of a curve, right? So let's do a is it clip? I think it's clip that. No, that's just gonna cut them off. Yeah, convert lines would certainly be something that you could use if you had maybe something that was a little bit more kind of already in a line format. That would just kind of give us all of our edge kind of lines in this case. But let's just do this. Let's try this. I'm just going to do this up here so we're a little bit out of the way. Can just maybe grab a grid here. No, there's a way to do this. What am I'm forgetting a node. Forgetting a node here. Sorry, let me think about this. What is it? What is it? What is it? No, it's not that one. Let me just double check something here. Grid. Boolean. I just want to see what this does. I know this does something sort of like what I wanted to do, but see, there we go. That's what I wanted. Perfect. Okay, this is what I wanted. Sorry. Anyways, I'll just make the grid a little smaller just to make sure we're not, I don't know, getting a decent number of points or whatnot. All right, so we've got our kind of little loop here of geometry. Let me see if we have any, I don't think we have any doubled points here per se, but all right, let's do that. Let's throw this through a resample. And let's just sort of make this a little bit cleaner. Let's do like a subdivision on it. Yeah, maybe something like that's good. Bunch of points, not too many. All right, so let's do, I think if we do orientation along curve, that'll be good as well. And let's just see what that gives us. Just as a, yep. So the orientation along curve is really nice because it's going to give us our normal attribute kind of in the direction of that curve, right? So that's obviously something that is, you know, is going to be beneficial for us to use, right? So we've got this orientation along the curve. We can take this now and instead of it being n, we can change it to v. We don't need our y-axis on it. So now we have a v velocity. Now this will look a little different. In fact, you probably can't even see it very well here because it's going to be fairly small, it would seem. Interesting. I don't know why that's not showing as well, but that's okay. I know it visualizes much smaller. Oh, weird. Did I have the wrong? I must have had the wrong one on. Sorry. Okay, so there's our velocity. It's just pointing kind of in the trailing direction instead of the like the direction it's heading. It's kind of trailing behind it. So okay, so we have that. So this is going to be get intersection curve resample. This is v from curve normal. Okay, so now we're starting to get somewhere. We've got our, let's see here. Here's all of our points. So this should work. And now what we can do is add this in to our velocity calculation, right? So if we take this and wire this into the second here, now let's think about what we're doing here. So now the difference is we don't want to be using this based on the distance or anything like that. We don't need to calculate it quite the same way. So let's do this. We're going to use this distance down here still, but this top section we aren't going to calculate quite the same. So what we want to do is just basically import those point attributes right from the nearest point. So what we'll do is we'll use the position here. We'll do near point. Use the position. And we'll use the nearest point from the second input, and that'll give us our near point number here. Now, this we won't be able to do from just 0 anymore because we're going to be, yes, exactly. It's not going to be a single point, but we're going to be pulling from the closest point to these individual voxels. And you could do this. Certainly you could make an array of points that are closest and blend between them. I'm not going to quite do that here because what you could just do is blend your velocity values and just have that kind of smooth everything out. In this case, having the closest one should be fine more or less, and it'll get the point across, I think. But yes, exactly. It isn't just one single point that we'll probably be wanting to take from. We'll probably want to take from a bunch, but in this case, we'll get them and then kind of see how it goes from there. We could always do loop over points and things like that if we need to. All right, so here's our nearest point. We're going to import, actually we can just use this because this is the position. So we're going to import its position here, like so. So now we have the position that'll be used for the distance, and then we'll also grab one over here and do this for the velocity, right? So this is going to import our velocity. This is going to be a vector. They're both vectors, so that's good. So let's put the result of this into the input there. Great, all looking good. And let's kind of adjust this a little bit here, because what we're going to see is we're going to start having these volumes kind of going like that. Cool. We might want to add a little more resolution to this. Maybe I'll just, yeah, that's good. Maybe we'll add a few more scattered points as well. Calculates quick enough so we can get a little more resolution on that. All right, so let's just adjust this a little bit here. So we'll have that go up a little bit. Bring this down like that. And now we should have those velocities that are going to be shaping kind of around this pig head here. So let's just, we'll keep this maybe like that. We'll just template it. Now, obviously, this isn't a collider in our simulation, so we're not going to be, we're not going to be using this as something that's going to be affecting our simulation, but we're using it kind of as a reference for our velocities. So if we play this now, we should start to see some movement around this object, right? And let's see, scale velocities. Yeah, maybe that's a little too high. We could always go to like 2, something like that. And we can see that this is sort of now rotating around. Let's turn this guy off. And there we go. We're getting kind of this custom rotational, activity from that, from that velocity. Now, I think what we're seeing here is actually some, a little bit of instability maybe in the Vellum solver. All right, let's just go a little higher with our substeps. I think that'll be a little bit better in the long run for our simulation. One good thing about substeps as well, on top of helping with stability, is that it'll also help with kind of smoothing out how this effect is going to work. It's calculating it at more steps throughout the process. Yeah, there we go. We're not really getting that kind of explosion of grains happening in that one direction. So that seems like we're in a good spot there. So we're starting to get somewhere here, right? Now, what we could do is start to kind of stack these things on top of each other, right? So what we could do as well is we could actually have, okay, so we've got our visualized velocities here like this, right? But what we could do is we could actually start bringing multiple velocities together, right? So we could have these all, we could have it either pull towards this kind of shape. We could have it push it away at first. We could actually animate some blends and things like that in the midst of this. So let's kind of play around with that a little bit, right? Because now we have some of these ideas in our heads kind of working, right? And hopefully this is starting to make a bit of It's actually, no, I don't think it would, it shouldn't be too bad. I mean, we're not dealing with a ton of points or anything like that. And this volume trails is not even needing to calculate. Like, it just calculates once. It's not even time varying. So this doesn't have to calculate all the time. Now, as you start to, as you start to add more things into it and kind of blend and merge between them, it will have to, reset or whatever, or have to be time varying, but just something, to keep in mind that right now these aren't time varying. So yeah, I know Ivan's been putting a lot of comments in the chat, and that's awesome. Keep going, Ivan. I love hearing from you and making sure everybody's good. If anybody else has any questions, you're always more than welcome to put them in the chat. If you think I'm doing something goofy or stupid, let me know. I mean, again, like I said, I'm kind of doing this off the cuff, off the top of my head. I know what I want to do, but I'm not, some of the steps are kind of, piecing them together as we go. So please feel free to ask questions, hop in the chat. Always glad to kind of answer any questions or thoughts that might be going on out there. Okay, so we've got this rotational idea happening here, right? So that's good. But what if we wanted to... Oh, dude, if you're understanding this, you're not a noob. And even if, who cares if you're a noob? Everybody's learning, man. It's always good. Nobody's a noob here. No, in a derogatory term. We're all learners, right? And that's kind of the fun thing about this industry, is that you're always going to be learning stuff. I learn stuff every single week. So, okay. So, so we have this distance attribute, right? And we have this, we're just importing our velocity, right? So what if instead of that, we now added in the idea of the distance between those, or the vector between those two as well. So we could actually now do the same thing we were doing before, where we bring in a subtract, we grab the position of the current voxel and the nearest point, right? So these are, this is now our current voxel and nearest point being calculated against each other. And let's just do this. Let's select those all. So if you hold down Alt, you can kind of organize yourself a little bit better here. So I'm just trying to organize this setup a little bit, just so we can maybe see a little bit better what's going on here. Cool. All right. So now we see that those are all going where they are. Great. So this position is getting distributed to all these. All right. So we have this subtract here. That is that is a fun one. Just holding down Alt, and that actually works in SOPs as well. So you can do that up here as well. So like if you had, like these, you can just hold down Alt and click them together. If you want to, go away. Go away, Dot. That is there's so many little tricks like that. It's insane. There you go. Veronica's right. Looks like Veronica's right there with you. Yeah. There is no such thing as a dumb question on this channel. And this honestly isn't noob stuff. This is, starting to control your own velocity fields and things like that. It's different than just throwing down like a pop wind and just kind of going with it. This is where you start to actually kind of blend and make your own shapes of velocities and understand how you can kind of control what properties on geometry are doing to your simulations through, forces and things like that. There is also, I just wanted to note that in here, there is also the, is it a vect by filaments? No, that's not the right one. I think it's curve force. Yeah, pop curve force. This is pretty similar to what we're making right now. We're kind of making our own custom pop curve force is more or less what we're doing. The reason that I'm doing this is because the curve force is great. It just pretty much only relies on the curve to drive everything. Whereas in this case, we can kind of operate on the entire volume and not have to worry too much about only what the curve is doing. It's just maybe a little bit more fine control and allows you to maybe think about ways. It gives you a way to be able to start going even further with these ideas, right? So anyways, all right, so we've got our curve force here. Let's also now get our distance here. So we've got the vector that's going to be pointing to the curve, right? And let's normalize that just to make sure maybe all of our vectors are going to be equal. And then let's first, before we do anything else, let's just kind of stick this back into, let's just wire this in here just to see what that looks like. There we go. That's what that force looks like, right? Alrighty, cool. And so now we've got kind of a suction force that's going to be sucking in towards this central kind of wire here. And obviously, if we were to take this like, so if we did this and changed where we're slicing this, right, we could slice our grid at different points. That would work like this, and these are all going to adjust. Or if we liked that shape, we could put, a transform here and move this shape up and down, right? Oops, it's a little too coarse. So the cool thing here is actually, you were asking before if it has to be inside of the volume, and technically it doesn't, because the volume, we're calculating it on the voxel. So as this goes outside, it's looking to this. They're all pointing towards this still, right? So it still knows where this is. It's just that the vectors are going to be a little bit different. So yeah, it still knows where they are, just slightly off. All right, so let's do that at like 0.05 maybe, so it's up a little bit. Cool. So now we know we've got our vectors pointing in. No, I'm forgetting. If we put it into this input here, this will give us, that looks like they're going in, because what I'm seeing here is that it looks like, exactly, yes, when they go outside of the box, they don't have velocity yet. So what Ivan's asking is, will it, when they leave that volume like boundary, they'll stop having that advection happen to them. They'll still have velocity. It's just they won't be affected by the advection anymore. And the thing to keep in mind too with that is that we are dealing with this as wind, right? So it's not, I think if we were doing this as update velocity, they might actually just stop when they got to the edge. So I'm pretty sure using it as a force is a much better way of doing it, but don't quote me on that. I can't remember off the top of my head. But anyways, all right, so we have this. And what we can do now is we could actually, let's see, what's the smartest way to do this so this makes good logical sense? Don't want to make this too complicated. All right, let's do this. Let's do a... All right, so I'm going to just change this. So we're going to call this, so we're going to do a couple different fits based on this distance, right? Because this distance is going to calculate for the entire range, right? So what we could do is, instead of using this fit to only have it be, bringing these particles closer when they're like this, we could change this, have another fit here. And I'm just going to change these guys here so that they're, see, these now think they're the exact same because they have the same name. Let's just do this. We'll do a new, sorry. All right, let me name these first. So we'll call this, we'll call them, there's going to be the, maybe curve force and suction force. So we'll say curve min, Oh, you know what? Did that just undo that? Sorry. Might have just freaked it out there. No, okay. I wasn't sure if I messed something up. Just want to make sure these have their own names. Curve min. And then we'll do make sure I'm naming those right. Yeah, I mean, you can name them whatever. So let's just call this curve scale min. All right, let's see if that makes a little more sense. I think what it's doing, as it's doing that, the reason the visualizer is changing is because it's resetting it back to its defaults. So as I changed each of those, it reset back to defaults for it, because I'm updating the parameter, right? So these are actually, these are parameters. You can see right here, but they're like kind of tucked in for ease of use. Like if I do this, if I do another fit, which I'm going to do in a second, and if I did well, let me just promote one of these. Just middle click, promote parameter. If I double click on that, this is actually a parameter like node. It's just tucked in visually here to make it a little easier so you don't have 20 of them sticking out. So it was just resetting back to its defaults. So here what we could do is we could say the suction force works up to about maybe there, and it goes out, you know, the maximum scale force is maybe there. And then, you know, we can set the minimum value to be a little bit, and we can, you know, we can kind of tweak how these all work, right? Maybe we'll leave that at 0. So there's our excuse me, our curve scale, right? And then what we can do is we'll do this here. We'll add our distance over here as well. And now if we look at the velocity like so, and we use a fit function on this to multiply here. So we just basically multiply this by all of these fits, right? I'm going to right click, create input parameters. And let me just check before I go too far to make sure that this is working properly. I'm going to edit the parameter interface just so that we have a separator here so we can visually see what the heck is going on. Cool. In fact, we can always edit the parameter interface and add a separator in here as well, just to make things a little cleaner. Let's see here. So now we should be able to set the distances for these, right? So let's do it like so. So we want, as we're in towards the minimum here, we want that to be fully scaling. And as we get close to the outside, we probably don't want any value out there. And what we're going to want to do here, I think, is not multiply this. Let's put this just out here. Cool. Great. So now we've got that rotating force right there. We're kind of back to where we were with that. more or less. And then we could do something like adding these together if we wanted to. I mean, it kind of depends on how... oh, right. I'm taking the wrong thing here. Sorry. This needs to be multiplied. This by this. There we go. And so now we're adding those together, right? But what we could also do is we could do something like a mix. And we could adjust the blend between them, right? So this is sort of a way that you could transition those kind of, you know, more easily. Now I'm just going to use this as kind of a way to kind of quickly blend these together more or less. Or actually, you know what? I'm going to do an add first, because what we're going to want to do there is actually have it blend based on distance as well. So it's kind of just using this distance trick a bunch of times kind of over and over to kind of set up different regions for it to be able to blend. I like that dog. What is that? It's a dog emoji? What is that? I apparently don't. It must be a reference to something. It's a very specific dog. Anyways. All right. So let's take a look at what this looks like and we'll kind of continue on. Why are we not getting that? Sorry. Why are we not getting that velocity pulling it inwards the way I'd like it to? All right. So yes, I'm using the wrong one. That's why. So you can see here as we adjust these values, we can kind of adjust how this is going to work. So let's see here. Could we give this a little more? Maybe like so. Yeah, that seems to be doing something a little bit better. Let's take a look at that. Why was it not doing anything at 2? That's weird. All right, sorry. So now we're kind of having these particles be pulled in. You know what I'm going to do? I'm going to turn off this coloring because it seems like it's actually getting a little distracting now. So let's do that. So we can see it pulling in these particles. Let me do this. We'll do like a trail. And they're starting to kind of move around here. Black and white color? Sure. Let's give that a shot. You know what? I'll do a maybe a white to red. Let's try that. Maybe that'll be a little nicer. Yeah, that's a little bit better. So there, now we can start to see how these, are kind of working together. Oops, sorry. And, the more you want to kind of calculate and work with this here, you could obviously adjust the, sorry, that's the curve force. I'm just making sure that I'm doing this properly. Just going to visualize this as I kind of work with this. And then sorry, I've gotten myself a little confused here for a second. Sorry. All right. Exactly. If you were animating a mix like that, it would start to actually adjust the forces and things like that. Exactly. All right, hold on. I'm going to take this out. I just want to make sure I'm doing this right. All right. You could, Zach, you're asking about pulsing the velocity or limiting when the particles were affected. You could certainly do that in DOPS. You could do that on the SOP level as well. Might be easier to visualize it at the SOP level because, obviously here we have like kind of our volume trail node set up that we could use to kind of check that out. I named these really badly. Sorry. Oh, I see what's going on here. I flipped these around. Sorry. I flipped them. Okay. That's what we want. We're just going to adjust this here, make sure. I think we're going to do it like this. Yep. There we go. That was what I was expecting. Okay. That explains why that was happening. Instead of adding and mixing, how about doing a cross product? Well, yeah. Could you do that? Let me think about that for a second. I just want to make sure I've got this sort of working the way I want it to so far, and then we can go from there. But yeah, that maybe that would work. What's that? What's a cross product? Ooh, that's basically when you give it two vectors, right? And say you have vector A and vector B here. What it's going to do is going to make a vector that goes perpendicular to those two, like that. So that's a cross product. All right. I don't want this to get too messy, but I'm trying to make sense of what I'm doing here. All right. Well, I guess what he's saying is, could you do a cross product here of this vector to the other one? I'm not sure if it would work, but I'm not a mathematician, so some of these things I might not think of off the top of my head always. All right, let me just jump back up here, make sure this is working now. Yep, okay, there we go. All right, so now if we did this, something like Oppenheimer mood. This should start to sort of do what it is what I'm hoping it will do. And the idea here is that I want actually even these curved ones to kind of have a little bit of pull into the middle as well. All right, so let's take a look at this, see what this does. Yeah, so I think actually the problem here is I think I might have too many particles to be able to make this happen nicely. So let's just do this. Make a little less maybe. Just trying to pack, I think, too many particles in there in the middle. Cool. And so what I would do with this, right, is I would have the ability to scale both of these things, right? So I would actually take this out. I would give this, like, promote this parameter, and I would say maybe like, actually I'm going to call this vortex, vort scale. And then down here, oops, just do another multiply. So these are just kind of, this is just kind of how you can scale these things. So promote parameter, I'll say this is attract scale. And oops. I'm just going to name these for my own sake and maybe for the sake of others. If anybody else ends up opening these up. Traction max distance. And then we'll say attract min scale. Yeah, that's working. All right, let's see here. Min scale. Just try to make these appropriate. Cool. Those look good. I'm just going to say I'll have to reset these again, but that's okay. I'd rather it be easy for people to understand what's going on here. All right. Now that I have those all named like relatively well, I'm just going to set these like so. Set these both to 1. All right. Now we're off and running here. We'll just change these around. So yeah, I actually probably want this to go a little bit more like that so that we're getting some interesting like kind of rotational vortexing type things there. So we'll just say the minimum distance is like that. Make sure it has the most force on the inside, probably the least on the outside. Maybe like that. What we can do is we can actually kind of turn these on and off just by changing these scales, right? So we could do this and we can just see the attraction scale that's working here. So we could just go, make sure it's pulling in from a decent distance. Let's see what that does. Ah, yes. We don't have... We're going to up the velocity scale a little here. Maybe we'll do this at like 2.5 maybe? Let's see. Yep. And maybe we want to do something where, maybe we need the attraction to be a lot stronger. Pull everything out. Can kind of play around with these a bunch of different ways. Obviously, you can do a ton with these. The other thing we could possibly do here is we could bring this up a little higher. Nope, too high. Yeah, the volume trails are super fun. I really like those. Those are always a lot of fun to look at. So I'm going to set the attraction scale much higher here. See if that... Oh, hey, bye. Oh, it went to 13. What the heck? How did that happen? Let's just make the attraction scale a bit higher here. Yeah, so you can see how you can kind of control this differently. Like if this maximum distance is going to be further away, it's not going to really, affect it from all of these such wide distances and things like that. Yeah, you could certainly set it to as a collider as well if you wanted to. So, could set it like this. The only problem is it's going to be starting kind of in the middle of these grains, right? I think there's a way to adjust that. No, but yeah, it's going to obviously move around it now a little bit differently. Problem is the stuff inside is also going to be sort of an issue here as well. Oh, right. Like, what's happening here? So yeah, if you do this, obviously it's going to be swirling around. The other thing I would certainly do would be add some noise into this. Let me adjust this vortex force as well. I think I lost something here. Don't really maybe want that vortex force to be going so far. All right, let's try that. Oh, I'm actually going to undo that. Yeah, so let's take a look at that, just to kind of show you the difference there. So you're asking what the difference is between force and velocity. So velocity is going to be a little bit different because it's going to be like really intense because it's actually trying to update the velocity per, step or whatever. So probably need to turn that down a little bit. So the force is literally just adding that force into it, whereas the actual velocity update is going to be kind of constantly, it's kind of hard. I guess it's kind of hard to explain. Like it's not quite, so there's also this update position, and that's like the most like locked on kind of setup where it's like literally trying to snap those, positions all the way to where the velocity would take them basically in that number of steps, right? Whereas when you're doing the update velocity, you're kind of blending between the previous velocity and this new velocity. So it's basically trying to match the velocity so it's trying to match the velocity that existed before and the velocity that you're adding in. It's blending those together with a blend of 0.5. Whereas the update force is basically just adding in kind of an air resistance force into this and is kind of dealing with it a little bit more loosely and allowing it to kind of flow a little bit more. And it's usually, I think, the best way to do it. But I mean, you can kind of try all of them and see which one gets you the things that you're looking for. I'm also going to add in just a little bit of noise here as well. So just do that. So let's just do a noise. Let's do curl noise. I always seem to see people using that one, so we'll just use that one. Got a curl noise there. I'm going to do the same thing I did before where I input parameters. And I'm just going to add that in at the end. Actually, I can just add that in right here. And so what we should see is now a little bit of noise in there. Yep. And actually probably a lot of noise. Let me just edit that parameter interface to here. We can just add some noise frequency in here. Don't want to add too much in, but just a little, maybe 0.5. Cool. Let's take a look at, oh, and we're going to want to have that varying with time. So what we'll do here is we'll just do a little offset. Just delete that node and get time over here. And what we can do is we can just do multiply Oh, Mohammed. Yeah, interesting. What a coincidence. I've been busy lately doing similar thing with logo, sand reveal effect. Ended up using a pyrosim to get a nice swirly motion. Yeah, that certainly is another option as well if you wanted to do something like that. Yeah, a pyrosim is a great way to bring in velocities and things like that. It just depends on how much control you want with something, right? So, yeah, it really can depend on if you want something to be a little bit more loose and feel like it's, you know, one sim kind of driving another in some ways, or if you want it to be a little bit more like locked in and specific the way that you want things to kind of, you know, follow along or whatever. So now we should have that. This should allow us to, oh, that was the wrong words. I typed the wrong words there. This should actually be timescale. Just typing words and not thinking about them. So that should adjust how this noise field will flow through. All right, it's kind of fun. Let's maybe make the attraction scale a little higher. Oh, interesting. It's detecting the range. That's why it's changing on me. Got it. All right. Anyways. All right, I don't want that attraction to actually go that high. Let's do it to like 2. I'm again going to adjust this just a little bit more. Maybe make a few less particles here because I feel like we just have too many particles here that we're kind of dealing with. They all want to jump into the same area. All right, so let's just adjust some of these and see kind of what it is we're dealing with here. So this is always the tricky thing with simulation, right? You've got to always kind of figure out what what the balancing kind of forces are here and how this best kind of works for you, right? And so now we have that force that's kind of swirling around here, doing some weird stuff, but ultimately we've got some noise in there. It's kind of affecting it as well. And we can kind of allow that to sort of, move around and affect this simulation kind of as it sort of evolves here and stuff like that. So what I'm going to do is, instead of just doing it where it's just kind of static like this, I think what I'm going to do is take this and now first have it maybe push away a little bit from the area where we all want it to kind of pull back to or whatever, like kind of give it some force to move it away. We'll have like a little animation maybe of this to make it a little bit more interesting, because this is just kind of static and is just doing its thing. So right now what we have is, so those are 1 and 1 and 5. Okay, so what we have is we have a kind of an attraction scale here. We have a vortex scale here. And we also have, let me turn this down. So there's our vortex scale. There's our attraction scale. And I think, yeah, we could negate that. All right, so this is what we're going to do. We're going to start with this attraction scale. And we can just kind of animate all these different these attributes. You could do it through a mix if you wanted to. That's certainly possible. But this way we can kind of flip these things kind of around and do some different stuff with them. What I'm going to also do, since these are going to push away, I'm going to make this bounds a little bit bigger. So let's just do copy parameter, paste relative references here. Hello? Why did it do that? That was weird. All right, so there we go. Let's just make this a little bit bigger. Okay, like so. The grain particles are default. Yes, they are. They're just default grain particles, nothing fancy with them. Yep, just default grain particles. So what I'm doing right now is just expanding the volume bounds. I'm not actually expanding the bounds of the particles. So just so that we have a bit more volumetric area to be able to work on, right? So let's do this. Let's set up a couple different aspects for this. So first, I'm going to turn off the simulation here so that we're not accidentally simming. And let's add a few more scatters in here. We should be able to go up to 5 maybe. Yeah, that looks good. Oh, I'm going to turn that off. And let's look at this. Okay, so let's first start with something where we push the force this kind of away, right? So we'll just set these all just back kind of their defaults. And here's our attraction scale. So this, instead of 1, we're going to go -1 on this. So this should flip all of our vectors to be the opposite direction. So this will push it away from there. So let's just see here. 1 and 0. Okay, maybe we'll just set this to 2 for now. That should be easy enough to read. All right, so I'm just going to reset these back so that they're kind of all at defaults, and we'll kind of make a little animation here. So, all right, so the minimum distance I want it to be full force there, and let's turn the force down maybe as we get away a little bit here. So this should, in fact, what I'm going to do is I'm going to change my interface. I'm going to go to the attraction scale. Yeah, that's fine. We'll do the float range to -1. So now I actually have this where I can just slide it and it'll flip. All right, so let's start it at 0. Here. We'll move this forward a little bit. Maybe to 6. And then up to 24, we'll animate it to -1. And our minimum distance, maybe we'll go like that. Okay, that looks good. All right, let's try that. And we'll just kind of see what that does to start our simulation off. So we should just have... Oh, right. Simulation's off. Let's restart it. And what we could do as well is we could maybe... maybe what we'll do is we'll actually add one more thing into this. Question is, how about mass regarding vellum grains? Do you find yourself tweaking it usually? I mean, you could. I haven't in this case. What is it set to right now? It's at set uniform. I mean, we could do calculate uniform. I don't know how different that's going to react. Yeah, I mean, it's not really going to do a whole bunch different. But yeah, I mean, if you had different sized grains, yeah, for sure. Doing different mass for them would probably make sense. Obviously you'd want to have like a varying mass, but, yeah, I guess if I was doing it with other elements in there, I would probably change the mass of them. But for right now, I mean, unless I had something to really compare it against, like say I was going for something really specific like snow or I don't know, something like that, then maybe I would tweak the mass. But right now I just kind of am just going to leave it. It's not really, I could do calculate uniform and that's going to give me a density equal to water roughly, right? So, if you had other things you were having it affect, then yeah, maybe. But all right, so we've got this here. It's kind of pushing away like that. And then maybe what we do is after about 48, just going to go here. And I'm also going to make sure that there's a little bit of amplitude in this at first. So maybe we'll have that right there. So we've got some amplitude there. Kind of pushes away. So here we have this maybe set to then I think from 48 we'll reduce the attraction scale to 0. And then maybe we'll add in a little bit more amplitude on this here. maybe like starting here, go from 2 to, I don't know, I think 0.4 might be interesting. Do that. And then we've got kind of some noisy stuff going on here. Let's see what that does. Turn our sim back on. Let's see, do we have any? Noise really isn't doing a whole lot on this. Interesting. Oh, there we go. It's starting to kind of pick some of the sections up a little bit. Push it away. And I think what we'll do is we'll start to kind of pull it back maybe right here. All right, so let's do this. So we'll start the attraction scale up. And for this, I think what we'll want to do is have higher attraction the further away we are. So I'm going to set those. Oh, wait a second. Did that? Yes, those were not those were animated. Okay. Oops. Okay. Set that up to 1. And I think what we'll do here is we'll just change this now. So let's see here. So we want this to attract far away, maybe a little less closer up. Or we want it to go all the way to the inside. And do this. So I'm going to increase that distance scale. I want this to be 0 here. So we've got some noise going through, and then it's going to go and pull them all back in like that. Let's see what that does. Yeah, I mean, you could do it. Yeah, you could do it any number of ways, right? You could do it whatever feels best for you. Like if you wanted to set all of those different properties up, you know, the way you had them or whatever, like if you had a bunch of you know, different setups that you wanted to blend between, you certainly could do that if you wanted to. Maybe a mix node would be the best. Yeah, there's like obviously a bunch of different stuff you could do there in order to sort of make the effect your own, right? Let's see what happens here. Yeah, so you're saying doing multiple volume VOPs, right? Like you could do yeah, I think I see what you're saying. So you would have, well, yeah, is there a volume blend? Volume mix, maybe? Yeah, Yeah, you'd have to do something like this, right? Where you'd have multiple like volume velocities, right? Because you're using volumes. So you could do that. You could have one that's like the beginning one that's the end one. You could kind of, yeah, you could do that any number of different ways. I'm just kind of playing around with it this way because, um, you know, it's just how I have it set up. So, you know, it could be simpler to do it another way, right? To have multiple nodes that kind of do individual effects, blend them that way. It's all, you know, very possible to do that, you know, kind of however you want to. So the other thing, yeah, of course. Other thing I'm going to do here is, I think this should go up even a little higher. Maybe we'll do 0.8 on that. Oops. And then we need to mix in our vortex scale. So let's do this. And so what we want to do with this is we want it to be, switch these around so it's like that. Yeah, it really, I think that was mostly what I wanted to do here. It wasn't that I have like some elaborate effect that's really amazing to do, but it's more so understanding kind of how these things can all sort of work together, right? Like there's so many different things that you can do here with something like this. Like it doesn't just sort of end here, right? Like this is cool and it's fine to like have, you know, interesting effects and things like that, but like, you know, doing something like this, the other thing maybe we could do, maybe which would be even more interesting, would be to have this as the, nope, sorry, not that, this as the collider, and let's see here. But not see it maybe in the end results. Let's just see what that does. Actually, you know what? I'm going to delete those on the inside. So let's do group. Let's do this. Source data, this. Actually, I'll do something like cull. Bounding regions, bounding up. We have some points. I'm going to do a blast node here for cull. Then we'll throw this back in there. Actually, do we need to? Right. I need to do the same thing actually for both of these. So we're just going to do this. And then I'm going to do an attribute delete because these have no attributes on them. We need the same number of points. And we'll do a group delete just to be super clean. Okay. Am I excited about Houdini 20? That's the question. Yes, I am excited about Houdini 20. I can't say anything about it yet, but it will be exciting. I can't say what I'm excited about yet, but I'm very I think it'll be a nice feature update. I think there'll be some great new stuff in it. Very excited. If you've seen any of the previews that we've put out, I think those have been pretty cool. And yeah, some fun things like like if you watched the FMX presentation, Kai showed some feather stuff, and I think there was some stuff from SIGGRAPH as well, with XPU. So that should all be really exciting as well, hopefully. So let's do this. Let's turn that color off. Let's do this. Let's just color these something. Just get rid of the color afterwards. Let's see what this kind of looks like. So we've got this that kind of shoots out like that. Maybe a little too intense on the sucking back in. So let's try to adjust that a little bit there. So this, the let's see, the reattraction is a little too high, I think. So let's do this. Let's do 0.5. Actually, I adjusted the attraction scale there, but that's okay. I can just do it globally here maybe, and that should be a little better. All right, let's see how this works. Kind of add some swirling in, and then things kind of get sucked back in and move around. I think the vortex is a little too crazy too. Let's see here. Yeah, it's a little too intense, that vortex. All right, let's try it again. But hopefully you can see how you get some really cool abilities to affect these different elements this way. Another thing you can do too is you could have multiple, advect by volume nodes, and maybe different groups would be advected different ways. That's certainly an option as well. So there's so many ways that you can layer these things kind of on top of each other. So I don't want to be too prescriptive on like, this is the way you have to do it, but just hopefully this gives you some sense of like ways that you could bring these elements together to create maybe more and more interesting types of effects. I think it definitely looks pretty cool with the invisible kind of collider in there. Makes it sort of interesting. Still think it might be a little too intense on that vortex. Maybe we go up a little bit on the attraction scale. Maybe they just meet in the middle somewhere in a happy medium. So Zach, you're asking, could you use an animated switch node between the volume VOPs and cycle between different velocity volumes? For sure. Yeah, you could definitely do that. You could also do a velocity blend on SOP level. That's possible as well. So if you had different VOPs that you had set up to do different types of effects, you could blend between them that way. I'm kind of doing everything in one kind of monolithic node, but yeah, you certainly could do that. In a bunch of different ways. So no doubt you could certainly do that. Um, Actually, I think the noise amplitude is also too high. So let me adjust that. And I think I'm actually going to up the attraction scale again. Cool. I'm glad this is helpful. And yeah, it's like I said, it's not really the end effect. I mean, you can tweak these things for days and days and keep iterating and playing with them and thinking, oh, I could add this effect in here and I could do this thing and I could tweak it this way. And like, again, there's a ton of different ways that you can create, kind of grain, velocity volumes and ways that you could affect this type of simulation. So this isn't obviously the only way that you could go about doing this. You could add in forces from different places as well. There's a lot that could be done. Yeah, so let me try one more thing here. Mm-hmm. Just changing the minimum scale here a little bit so that it still pulls it in, even when it's kind of in this far, let's see. Okay, 327. I'm just doing this blind, but that's okay. Let's see what that does. Just want that not to be pulling maybe quite so hard. Oh, dynamic simulation disabled. Turn that back on. All right, let's see what this does. I don't know. Just playing with properties here, but yeah, this will be online if you want to take a look at it and play around with it and come up with your own properties and set things up your own way. You can certainly download this. Go to the Discord server. Oh, almost knocked my water over. HoudiniHangout.com. You can get an invite to the Discord server there, and there's a channel or whatever to kind of where you can go and download the files from the past streams. maybe the problem here is that I am just maybe doing that a little too quick. Maybe that's it. Let it go a little longer. All right. I think I'm probably going to be wrapping up shortly here. It's been a little longer than normal, but if you guys have any more questions or thoughts or anything like that, happy to answer them before I shut the stream down for the evening. But if you do have other questions, happy to kind of go into them and talk about them or whatever. But I'll probably be wrapping up here in a few otherwise. Cool, Zach. Yeah, glad to be able to help out, and yeah, that's great. Glad you're learning stuff. Something like this with RBD collisions. Oh yeah, that'd be kind of interesting. Yeah, like chunks of a building or I don't know, like rocks and stuff. I mean, it would be very similar to do this, right? Like you could take, all of these. No, it certainly would not be a problem with RBD. It wouldn't be an issue at all. Really, the process is very much the same with RBD, right? Like RBD is just points. So if you brought in a pop, adjust advect by volumes into a RBD sim, it would do pretty much the same thing. I mean, it wouldn't be really all that different, from what from what we're doing here. Really, it'd be very similar. All right. Well, I'm just going to save this and close things down for the evening. I really appreciate everybody coming out tonight and chatting. It's been really fun. Always nice to have a lot of questions in the chat. Yeah, thanks, KG. Yeah, give it a shot. Yeah, play around with it. I mean, this kind of technique can be done in a lot of. Yeah, exactly. Zach's saying about how much geometry that Houdini can handle. Yeah, for sure. It's a lot. You can kind of throw a lot at it and it'll kind of just keep chugging like right along. So just keep in mind that all of this stuff can be brought into other simulations as well. Like we're using the pop advect node. You could certainly inject velocities into a smoke simulation. You could use the pop advect in a fluid simulation if you wanted to, because those are particles as well. So you could do that at the particle advection stage, or you could use the velocity volume as a volume to affect maybe the volume motion. So there's a lot of different things that you can do with a ton of different simulations within Houdini with just the concept of using velocity volumes. So hopefully this is an interesting kind of new thing for you if it is new to you. Maybe it just gave you some different ideas to play around with or ways to kind of go about doing things. I mean, this is just the tip of the iceberg. Obviously, the stuff that that Mark was doing in that example on the Discord server, that's really advanced stuff, and you're playing around with tons of different noises and path following and different things like that, and attracting in different ways. So you kind of have to play around with a bunch of different things in order to get, to dial those things in perfectly. So, play around with this stuff. Take a look at the files that are here, and hopefully maybe this will give you some new insight and ideas on how to do things. But that's going to be it for me for tonight. Hope everybody has a great rest of their week and weekend, and I'll see you guys all next Tuesday or Monday for another edition of Mops Mondays. I got some ideas. I was talking to Henry a little bit, so we got some ideas for that, and maybe look into some tools and things that are a little bit kind of outside of the norm for what people think of when they think of mops. So we'll play around with those and see kind of where we get. All right, everybody, have a great night, and I'll talk to you later. Bye.